Welcome. In this lecture, I will take up the mass and weight and the difference between mass and weight. But before making you understand the basic of mass, I think it will be helpful for all of us to understand the word called inertia. How the term inertia came into the being, I will explain you, and it will be starting from 3rd century BC. A scientist was there named Aristotle, who gave some understanding of the rules of motion, and then came Galileo in 15th century AD. As you can see, there was a 2000 years difference between Aristotle and Galileo. So what Aristotle told in 3rd century BC was accepted by the people for 2000 years, till Galileo proposed his hypothesis based on his own experiments. So what Aristotle defined was, he defined motion as of two kinds. One is natural and another is violent. He defined these two kinds of motion, Aristotle. So Aristotle defined, as I have told, natural motion and violent motion. So Aristotle said that every object in the universe has proper place determined by its nature, that is nature of the object. And as per Aristotle, there were two kinds of motion: natural motions, either moving up or moving down, and objects seek their natural resting place. Like when apple falls on the ground, the resting place of the apple is ground. The clouds moves up because their natural resting place is above, so the clouds moves above. So the objects seek their natural resting place as per the Aristotle. He also said that heavier objects fall very rapidly and as compared to the lighter ones, and the speed of the fall depends on the how the heavy object is. He said that heavier objects fall quickly, and lighter objects take more time as compared to the heavier object to fall from a given height. This Aristotle told in 3rd century BC. And then violent motion. Aristotle, the second type of motion was violent motion. As per Aristotle, the violent motion resulted from push or pull on the object, that is, an external force. Aristotle was of the view that to keep the object moving, a continuous force is required to be acted on the object, that is, a sustained push or pull is required for the object to keep moving. This was the hypothesis of or the what Aristotle understood from the basic understanding he had at the time of 3rd century BC. That is what he said. The second part he said is, suppose a body is moving from here to here. He said some force must be acting on the body all the time when the body is moving from this place A to B. What he said: force acts on the body whenever the body moves. The body moves. That is, continuously the force is acting till the body is moving. Body is moving. This what Aristotle has told. So there were two major things about Aristotle. First, heavier things falls quickly. What he said, why I already explained in the natural motion, quickly. This Aristotle has told. Second was continuous force is required. Force is required to make the body move. Body move, right? body move. This was the understanding of Aristotle at the time of 3rd century BC, and his understanding was in the uh, parlance for about 2000 years when Galileo comes into the picture. Galileo Galileo came. These were major understandings, and both were wrong. Both wrong. Galileo proved both the hypotheses as wrong, and he defined a term called inertia. I will explain. What Galileo did, there is a tower called Pisa Tower, inclined Pisa Tower. It is inclined to the Earth's surface. It is not straight up. He went into at the top of the tower. This is Galileo. This is Mr. Galileo. I have shown it. What he did, he took two objects of the same size. Size was same size, but suppose these objects are A and B. But object A was heavier than object B. The same size was taken so that the friction forces which act on the both the objects remain nearly the same. The size and is nearly the same, so that friction is size taken same, so that friction, that is air drag in this case. Air drag. What is air drag? That is air opposes the downward motion of the object. Air drag remains same on both the objects. So what Galileo did, he climbed to the Pisa Tower. It is a famous tower, and he called many public to stand in the ground who was watching the experiment, and he dropped both the balls, A and B, of same size, and one was heavier and other was lighter. So what he observed that both A and B fall on the ground at the same time. So he challenged the hypothesis made by Aristotle in 3rd century BC that heavier objects fall quickly, and the speed of the heavier objects depend on the heaviness of the object. And it was challenged by Galileo, and he proved that it is rightly said that both the objects took nearly the same time in reaching the ground from Pisa Tower. Now you just think about what was happening in 5th century BC, 15th century AD, when Galileo was performing the experiment. It was 15th century AD. There were no tools and tackles available, and a lot of people were standing on the ground watching this experiment, and Aristotle was believed to be right at that time. However, Galileo came with a different observation. Galileo was a student of Aristotle. He was a student. He was a uh, in another experiment. Galileo observed that if the ball is rolled, uh, if ball is left on a inclined plane, the speed of the ball increases, and if the ball is rolled upward with a on an inclined plane, the speed decreases, and ultimately ball comes to a rest position. So what Galileo said, in one case speed is increasing when the ball is rolled downward, and another case when ball is rolled upward the inclined plane, the speed increases. So what he said, that what will happen if the ball is rolled along a horizontal plane? Will the speed remain constant? Will the speed remain constant on a horizontal plane? He observed that speed indeed remains constant, and the ball keeps on moving, and after a long time the ball comes to the rest, and that it comes to rest because of motion, or because of a force of friction acting on the ball which opposes the motion. The speed of the ball remains constant. This was the second experiment he performed, and it was again opposite to what Aristotle has told, that to keep a body in motion an external force is continuously required. Here the ball is moving from here to here, and there is no external force acting on this ball. Nil external force is acting. In another experiment, what he took was a tub kind of a shape. This is a tub kind of a shape, and nearly frictionless tub. What he did, he rolled a ball from a particular height h. He rolled the ball down in this direction. Hindi observed that after moving this distance, the ball again reaches nearly the same height h. Height is slightly less because of forces of friction acting up on the ball. Then what he did, he remained the angle of the first. This is, suppose, is the first plane. This is the second plane. He maintained the angle of the first plane same, but he decreased the angle of the second plane like this. This is the first plane. Now this is the second plane. So again he dropped the ball from here. He dropped the ball, and this is nearly frictionless surface. So what he observes, that the ball again reaches the same height. However, the distance covered distance is much larger in this case. Suppose this is case 1, this is case 2. In case 2, the distance covered by the ball is much larger to attain the same height. Here the distance covered this much distance, AB. So distance covered so he observed the distance covered is much larger in this case when the angle of the slope is less. So he said what will happen if angle of the inclined plane AB AB is made horizontal. As you can see, when the inclined plane angle is less, it covers more distance. So you keep on reducing the inclined plane, the distance d will keep on increasing. So he said, suppose there is a horizontal plane, then he observed that if the tub is pure horizontal, then ball keeps on rolling till it is stopped by the opposite forces of friction. It keeps on moving. And no external force is acting on the ball to make it move from here to here. So what is observed? This was purely opposite to what Aristotle has told. What Aristotle has told, I have already explained. Aristotle told continuous external application of force is required to make the ball rolling, to make the body move. However, Galileo told once the ball starts moving, once the body starts moving, there is no requirement of external force. There is no requirement of external force to keep the body moving. And he proved it from the two experiments which I explained in the earlier slide, uh, rolling ball on an inclined plane and the tub position. So Galileo uh, contradicted two hypotheses of Aristotle, that is, all the objects take same time to reach the ground if they fall from the same height. Second hypothesis of Aristotle, he proved wrong, that no external force is required to keep the body moving once the body is moving. And this hypothesis of Galileo, that is, in absence of any retarding forces, that is friction, mostly friction acts, retarding forces, the ball should not lose any speed if it is rolled on a horizontal plane. In inclined planes, the ball loses its speed because of motion, the forces of gravitation acting opposite to the motion of the body. That is, ball has a tendency to move forever without slowing down. If the ball is rolling, ball is moving. Now suppose take the case of a bow and arrow. Suppose this is a bow and this is arrow, right? I will explain what Aristotle told and what Galileo told. Now you pull this, this is arrow, this is arrow string. Now what you do for this, you just put this corner in the arrow string and stretch it as much as possible. Suppose you stretch it up to this height, up to this length, then tension in the string increases, and once you release the tension, the arrow moves in this direction. So what Galileos told, that once this arrow is moving, there should be some external force which is required for this arrow to keep moving, but it is not there as we see normally. What Aristotle told? Aristotle told that first external force is required. External force is required even after arrow has left the bow. But Galileo told that no external force is required. Force is required once the body starts moving. Body starts moving. That is, only external force is required to give an initial push and pull to make the body move. But once the push and pull has been removed and body starts moving, no external force is required to make the body move. That is, body resists changes in his state of affairs. Body resists the change in motion. That is, if the body is at rest, it wants to be at rest. Second, if the body is moving, it will keep on moving. It will like to keep on moving. And resist any change in the motion. That is, resistance is there both in the condition of rest as well as in the condition of motion, and this property of resisting the change is called inertia. Resistance to change. From rest to motion, and motion to rest is called inertia. Right. This is the basic concept behind inertia, which was given by Aristotle, and Newton further refined this concept of inertia and gave Newton's first law of motion. I will just write the Newton's first of motion, because this is not the chapter on Newton's first law of motion. This is chapter on simple motion for class 7th. What is Newton said? Newton's first law. It is based on Galileo's experiments. He said every object every object continues in the state of rest in the state of rest or uniform speed in a straight line unless acted on by a non-zero net force. So what is the meaning of this? Earlier we have understood that rest body in rest will keep on the rest. To change the state of the body from rest to motion, non-zero net force is required. For body to change from motion to rest, again non-zero force is required. This is called Newton's first law of motion. Now why it is required? To make you understand the difference between mass and weight. It is required. I will tell you. In chemistry, you must have heard the definition of matter. What is matter? Matter is a thing which occupies space and has a mass. Is a thing which occupy space and has a mass. In chemistry you must have read this in your class 6th or 5th, that what is matter? Anything which occupies space and has a mass is called matter. So matter is related to mass. And mass and matter are equivalents. Unless a body has a mass, you cannot say it is a matter. And another concept of mass is related to inertia. Concept of mass is related to inertia. As we have already understood that inertia is resistance to change. Inertia is resistance to change from rest to motion or from motion to rest. Change. And mass quantifies means numerically quantifies the inertia. What is the meaning of this term? What I have written? I will explain. This statement tells more the mass, more is resistance to change. Between rest and motion. Suppose you have two balls. This is a small ball and this is a big ball. Suppose this ball has a mass of 10 kgs and this ball has a mass of 100 kgs. 100 kgs and 10 kgs means these are matter. And suppose you push both the balls, then which ball you will be able to push more easily? Obviously 10 kg ball will be pushed more easily because it has less mass as compared to 100 kg mass. So inertia of 100 kg is more than inertia of 10 kg. So what is mass? Mass has to equal matter and inertia. Its unit is its SI unit is kgs. Kg. That is, more the mass, more the inertia, more the mass, more is the matter contained in the body. And now suppose in case of motion, suppose this same 100 kg ball and same 10 kg ball are moving with a constant speed. Suppose speed 3 meter per second. Both this is 10 kg, 100 kg, sorry. This is 10 kg. Now you want to move both. You want to stop both the balls. Which one you would like to stop, and which will be easier to stop? The second ball will be easier to stop. As it has less mass, that is less inertia, right? So I have defined the mass. Now I will define the weight. What is weight? Weight is just is equal to force of gravitation acted on the mass. What is for weight? Suppose you have a mass of 10 kgs. You just multiply it by the gravitation constant g, so its weight is 10g, and its unit is kg meter per second square, or is equal to 10 newtons. So what is weight? Weight is equivalent to force. What kind of force? Gravitation force. And what is mass equivalent to? Mass is equivalent to matter, and mass is also equivalent to inertia. Now in the class 7th book prescribed to my son, there are two balances to measure mass and weight. Please remember, weight is just a force of gravitation acted on the mass, and mass quantifies the inertia, or it quantifies the matter. So by this I complete the total concept about motion as given in class 7th of the book of my child who is studying in CMS Lucknow. Hope he might be able to understand the basic concepts of motion. And now I'll stop this long lecture. Thank you very much.